When we talk about relational databases, there are two different implementations of relational databases. You can have an OLTP database or a data warehouse implementation. So what exactly is an OLTP database and data warehouse? OLTP stands for Online Transactional Processing Database. That is, when you create an application, any kind of application, you are likely to have an OLTP database behind that application. It organizes the data in multiple tables in a normalized manner. What is normalized manner? We will learn about normalization next, but for now, think of it in organizing data into multiple tables. It does not like duplicates. An OLTP database organizes data in a very efficient manner. It puts the data in multiple tables and creates relationship between them, and that's why they are called relational databases. Now the problem with OLTP databases, even though they are an efficient way of organizing data, that is organizing data into multiple tables. For example, if you're creating a database for an online retail store like Amazon, you're going to have the product information in one table, the order information in another table, the customer information in another table. So the data is spread out into multiple tables and there will be a relationship between those tables. Even though it is an efficient way of organizing data, the problem with OLTP databases come when we are going to generate reports. When we generate reports, we have to create join statements between all these tables. We have to write queries where we are going to join the data from all these tables to generate our reports. Now, creating joins between multiple tables is very time consuming and inefficient. So when it comes to generating reports, we wish we had as few tables as possible. So that's where the concept of data warehouse comes. You can use the same relational database software as both OLTP database and a data warehouse. For example, if you're going to use SQL Server as an OLTP database, SQL Server can also be used as a data warehouse. Same thing with Oracle. Because the difference between an OLTP database and a data warehouse is how we organize the data. The data is organized in as few tables as possible. We don't really worry about duplicates, but we want the data in as few tables as possible so that we can efficiently run our reports. Our queries will be fast, and that's the main criteria. The report generation should be fast. So what they do is they take this data from an OLTP database, extract, transform, and load the data into as few tables as possible in the data warehouse. So this ETL process is carried out in what you call a DSA or a data staging area. So if you have an application, behind the application you have OLTP databases. Data organized in an efficient manner, in a normalized manner. A data warehouse has the same data in as few tables as possible. Duplicates are fine here. The aim of a data warehouse is we should be able to generate reports as quickly as possible. So what we do is we extract the data from an OLTP database, send it through a data staging area where we extract, transform, and load the data into a data warehouse. So when we talked about OLTP, we talked about that it was normalized data. So what is normalization? For example, let's take a look at this particular table. Imagine this table is like a book rental agency or movie rental agency. So we have data like this. Linda Berry of First Avenue has borrowed Atomic Habits and How to Win Friends and Influence People. John Doe of 3rd Street has borrowed A Time for Mercy and The Innocent Man. And John Doe of 5th Avenue DC has borrowed The Last Juror. They also have the routing, bank information. Maybe they have the account number, things like that over here. So this is for their billing purposes. So this is data organized in a table. Now, if we want to organize the data and store the data in an efficient manner, we have to normalize the data. Now, there are different types of normal forms. It used to go up to like 6th normal form, but nowadays, if you can go up to the 3rd normal form, that's more than enough. As a matter of fact, some people even stop at the 2nd normal form. So let's look at what exactly is this normalization. What are these normal forms? The first normal form says each table cell should contain a single value. So if you look at this particular table, this cell right here has two values. It has Atomic Habits and How to Win Friends and Influence People. Same way this one has a time for mercy and the innocent man. So it has two values. So the first normal form says each table cell should contain a single value. And each record needs to be unique. So these are the two rules for a table to be in first normal form. So let's reorganize this data in the first normal form. So now let's take a look at this table. This table is in first normal form. The same data has been transformed to first normal form. So here you can see that Linda Berry of First Avenue has rented Atomic Habits. Linda Berry of First Avenue DC has rented How to Win Friends and Influence People. John Doe of 3rd Street DC has rented A Time for Mercy. John Doe of 3rd Street, The Innocent Man. So you can see that every cell now has a single value and every record is unique. You can see that Linda Berry has borrowed Atomic Habits. Linda Berry has borrowed How to Win Friends and Influence People. So you can see that every record is unique and at the same time, every table cell has a single value. So now this table is in first normal form. Now before we move on to the second normal form, let's understand the concept of a primary key. A primary key is a single column value used to identify a database record uniquely. So what do we mean by that? If you join a company, they will give you an employee ID. So that's likely to be your primary key. So this is how they identify you. Same way in the US, they will give you an SSN number. So that is how the government identifies you, a number. So that is likely to be the primary key of your record. That is a number to identify you. It's usually a number, but of course it can have text too. The reason they avoid text for primary key is, like for example, if you take a name as a primary key, multiple people can have the same name. So usually primary keys have numbers and some primary keys may have numbers and text. It's very rare for a primary key to only have text because when you have something like a name, it can be easily duplicated. There are certain other things for a primary key. Like for example, a primary key cannot be null. That is, if you have a record, you cannot have a null primary key. A primary key value has to be unique, as we learned. A primary key value should rarely be changed. Of course, once you join a company and they give you an employee ID, they'll never change it. It doesn't matter whether you change departments or you got a promotion, they will never change your primary key. Same thing with SSN numbers. Your government ID numbers will never change till your death. The primary key must be given a value when a new record is inserted. We know that as soon as we join the company, the first thing they'll do is give you an employee ID. They won't let you insert a record without the primary key. Now, what exactly is a composite key? Sometimes what happens is, if you cannot have a single value that is unique to be defined as a primary key, then we will see if a combination of two values make it unique. For example, the name here cannot be the primary key because we have two different people with the same name called John Doe. This John Doe belongs to 3rd Street DC and this John Doe belongs to 5th Avenue DC. These are two different people but with the same name. So you cannot have John Doe as the primary key because it is not unique. But a combination of two columns, are they unique? Yeah, John Doe of 3rd Street is a unique combination. It is different from John Doe of 5th Avenue. So if you combine two columns and they are unique, then it's considered a composite key. Now let's look at the concept of second normal form. The second normal form rule says, first be in first normal form. That is, make sure that every value is in its own cell and every record is unique. So be in that rule. And the second rule is, the record should have a single column primary key. You cannot have a combination primary key. You cannot say like, hey, the combination of these two are unique. No, we want to have a single column primary key. So the only way to transform this data to have a single column primary key is to split up the data into multiple tables, something like this. So let's take a look at it right now. So now we are going to have one table for the members with their membership ID. Like for example, Linda Berry will have a membership ID of 100, John Doe of 3rd Street will have membership ID of 200, and John Doe of 5th Avenue will have membership ID 300. And the books they rented will now be in a separate table, something like this. You can see that right here, the membership ID 100 has rented Atomic Habits. Membership ID 100 has rented How to Win Friends and Influence People. So that means Linda Berry of member ID has rented these two books. John Doe of 3rd Street of member ID 200 has rented A Time for Mercy and The Innocent Man, and John Doe of 5th Avenue of member ID 300 has rented The Last Juror. And this member ID is the primary key. So we can see that these two tables are now in the second normal form. So now you can see that we have brought this table into the second normal form by splitting them into multiple tables. So the second table has its own primary key, like say rental ID, which is also unique, 1, 2, 3, 4, and 5. And this member ID, whose sole purpose is to create joins between the primary table and the secondary table, is considered the foreign key. It's considered the foreign key. So the member ID is the primary key right here and the foreign key right here, because the purpose of this member ID is to create a join between these two tables. And the rental ID is the primary key of this table. It is unique for every record. Next, let us look at the concept of referential integrity. So what exactly is referential integrity constraint? Once you have a foreign key which references the primary key of another table, it won't let you insert records into the second table without that foreign key being present in the primary table. For example, you cannot enter a record with member ID 500 because 500 does not exist in the primary table. You can only use member IDs 100, 200, and 300 in these records. Because this is the foreign key, it maintains the referential integrity. That is, it won't let you insert records with numbers that are not there in the primary key of the other table. Imagine this is the employee table and this is the salary table. You cannot enter a salary for an employee ID that does not exist in the employee table. You can see that it ensures row in one table have corresponding rows in another. And unlike the primary key, they do not have to be unique. Of course, like you can see that the member IDs repeat, that's okay. Now, before we move on to the third normal form, let us understand the concept of transitive functional dependencies. Now, let's take a look at this particular table right here. So Linda Berry of First Avenue has this routing number and bank name. Now, every bank has a unique routing number. Like for example, Bank of America, if it has 1, 2, 3, 4, all over the world, they refer to Bank of America with 1, 2, 3, 4. So the routing number is the same for that particular bank all over the world. So you can see that the routing number 1, 2, 3, 4 is associated with the Bank of America, and 5, 6, 7, 8 is associated with Citibank, and 1, 2, 3, 4 here is once again associated with Bank of America because the routing number goes with the bank name. Now, the transitive functional dependency is when you change one column, you are forced to change another column. Like for example, imagine John Doe of 5th Avenue decided like, you know what, I'm going with Citibank. So what happens is when they are updating the data, and imagine they are updating the routing number, like this one to 5, 6, 7, 8. They have to remember to update the bank name too, because the routing number goes with the bank name. If they update this to 5, 6, 7, 8, they have to update the bank name to Citibank. So that's what you call a transitive functional dependency. One column dependent on the other column. Now let's look at the third normal form. Third normal form first says be in second normal form. That is, first be in first normal form. Make sure that every cell has one data. Make sure that every record is unique. Make sure that they have a single column primary key. And the third normal form says it should have no transitive functional dependencies. That is, when you're updating one column, you should not be forced to update another column, because if you have such a dependency, people may forget to update it. The developers may forget to update both the columns. So that's what the third normal form is. So if you look at the tables right now, we have removed that particular bank name away from here, and we created another table with the routing number and the bank name. So now what happens is, I can go here and update it to 5, 6, 7, 8 for John Doe. I don't have to worry about it. And then while querying the bank name, I can use a join statement. I can like join the data. What is 5, 6, 7, 8? The 5, 6, 7, 8 is Citibank. So I just need to worry about updating this data. What banks do these routing numbers point to? They are in a separate table. So the data now here is in third normal form. Most modern applications go maximum up to third normal form. Some may even stop at second normal form. So this is what we call normalization. Data in OLTP databases, that is the databases behind applications, are usually normalized. But you can see the issue right now. The data is now spread out in multiple tables. If I have to create a report, I have to join all the 3 tables. Join queries take a long time when it involves like millions of records. So what they will do is they will extract the data, transform it, and load it into as few tables as possible. Because when it comes to generating reports, we really don't care if the table is like this. Yeah, there are duplicates, but you know what? I can quickly generate the reports. So this is normalization.